Hello, everyone. Today we're going to talk about the real-world use cases and how they relate to Stellar ecosystem protocols, and specifically how they've adapted these protocols, how we've changed them and modified them as the crypto and Stellar ecosystem as a whole has matured, and we've seen a change in different architectures and use cases that have arisen. So to introduce myself, my name is Jake. I'm a senior software engineer here at the SDF. I've been here for about 2 years. And one big part of my job is that I maintain a good chunk of the Stellar ecosystem protocols. And I also build tools that implement these protocols, specifically our reference anchor and a framework that enables or powers that called Django Polaris. So before we dive into the subject matter, I just want to do a quick overview, and just for those of you who may not be familiar, about what Stellar ecosystem protocols are. And Stellar ecosystem protocols are not like the Stellar consensus protocol, where nodes use a low-level networking protocol to communicate with each other, but it's actually an application layer communication protocol where applications are communicating with each other using the Stellar blockchain, so that the participants in the network can communicate in a standardized way. And what this does is it allows new entrants to the Stellar ecosystem to immediately integrate with all the existing services that are already there and are already compatible with these protocols. And so it just lowers the barrier to entry and multiplies or accelerates those network effects that we're looking for and trying to get more and more businesses and more activity on Stellar. So, for example, some of these Stellar ecosystem protocols, the one that we're going to talk about the most is the on and off ramp protocol, or what we call the hosted deposit and withdraw API. And what this does, for example, is I, as a user, if I have a Stellar account or I have funds in my Stellar account and I want to get cash or have an ATM withdraw, or not ATM, ACH deposit into my bank account, I can work with an anchor, and we'll go over what those are in a second, who exchanges my fiat currency or my cryptocurrency for the other crypto, or for the other asset. So I can give crypto to an anchor and they give me fiat, and I can give fiat to an anchor and they give me crypto. And I do that through a wallet. And this wallet and anchor have to both implement the standard specification that enables them to talk to each other and facilitate this action. So in this talk, we're going to talk about 3 different use cases. The first is custodial Stellar accounts. The second is wallet identity verification. And the third is off-chain liquidity. And these are very broad topics, but we're going to narrow them down to how they apply to the Stellar ecosystem protocols. And I'm going to show you how a user and the organizations facilitating a transaction use or enable these use cases via our protocols. So let's jump right in. So the first one we're going to talk about is custodial accounts. Now, custodial accounts are just Stellar accounts on the Stellar network, but the difference is that instead of me holding my own Stellar public and private keys, I actually outsource that to a custodian, and a custodian essentially manages and secures the private keys to my Stellar account, ensuring that they don't get hacked and my funds remain mine, and they are secure. Now, I'm also going to talk about custodial solutions, and there's an important distinction, which is that some organizations aren't legal custodians. They aren't legally licensed to hold funds on behalf of their users, but what they do offer is an additional layer of security that effectively ensures that neither you nor they have direct access to your Stellar private key. And so that's what a custodian is, and we're going to kind of go into that, and you'll get a better idea as we go through the talk. So when we first created SEP24, or the deposit and withdraw specification, the architecture that we had envisioned was very simple, and it looked a lot like this. We had a user who owned a single Stellar account, and we had an anchor at the other end that also had a Stellar account. And the idea was that if I was trying to facilitate a withdrawal, as I explained earlier, I would send my USDC to, for example, a USDC to the anchor and send it from my Stellar account to theirs. And the anchor would then send me US dollars via an ACH bank deposit, or I would go pick up cash. And this transaction would be facilitated by the wallet who's sitting in the middle. And the wallet and anchor would be communicating using these standard set of APIs that SEP24 defines or SEP6 defines. These are both deposit and withdraw API specifications. And what we found is that the architecture is a little bit different than that. One of the main differences is that wallets, instead of having or assigning individual Stellar accounts to each user, actually pool funds in a shared account or a pooled account. Now, in this case, I'm actually not the account holder anymore if I'm one of these users. I have a user memo that was assigned to me by the wallet. And this memo allows me to know, or allows the wallet to know, actually, how much of the funds in this pooled account are mine. So when the wallet interacts with the anchor, it not only specifies the shared account, but it also specifies the memo. And this is how the wallet and anchor know that the wallet is shared, or that the account is shared, and that my user memo, that me as a user using the service, is distinguished from other users that have the same pooled account but a different memo. And this architecture can actually get a little more complicated pause that thought. One thing I want to note before I go deeper into this architecture is that I'm using memos in a lot of my examples where there's a Stellar account and there's a user memo. And as a user, I have to know both, often to facilitate transactions. For example, if I'm withdrawing from Kraken, I have to send my funds to a Kraken-owned address, and I have to specify a memo. And this memo ties the transaction to me as a user trying to request the withdrawal. One thing that Stellar has introduced recently is the introduction of multiplex addresses. And these are effectively Stellar accounts with memos encoded into them. So instead of starting with a G address, they start with an M address, and they're slightly longer because they're encoding a user memo. And so the difference and the advantage of using these multiplex addresses is that I don't actually have to remember two different things, the Stellar account and the memo, right? I could potentially forget to provide the memo and send a transaction and realize that I had to actually, add the memo so that the service knew where to assign funds. In this case, there's only one piece of information that as a user I need to know. And that piece of information is actually encoded on chain too. So no information can be lost at any point during the transaction. So that's a little primer on multiplex addresses. But whenever I use memos in this presentation, multiplex addresses could be subbed out. They're equivalent and they encode the same information. So as I was saying, this model can actually get a little bit more complex because sometimes the owners or the managers of pool accounts don't actually want to manage the pool account. They want to add greater security and use a solution that specializes in securing these funds. And especially if they're pooled, they have a lot of funds in them, right? So using a custodial solution is very important. And in this case, as I'm showing here, the anchor actually doesn't hold the private keys to their Stellar account and instead uses a custodial solution such as Fireblocks or BitGo or Wire that uses that has an additional layer of security that actually manages the Stellar account and provides a set of APIs that allow the anchor to access and take advantage of all the Stellar native functionality without actually holding the private key and being responsible for managing it. And to make this even more complicated, using a custodian is not limited to anchor organizations. Wallets who may hold funds on behalf of their users could use this custodian as well. And so there's a lot of different variations that could arise from this. The anchor and wallet could use the same custodian. There are, a lot of different variations on how this could look. And so this is just going to show what our protocols need to support and need to be built in a generic way to kind of support this variation in the ecosystem. And so again, to recap, this is something that we did so that we could support these variations. And specifically, what did we do to our protocols to enable this support? Well, we did two things. The first was that we adapted our Stellar Web Authentication Protocol, or SEP10, and this authentication protocol is something that is a prerequisite for initiating transactions in most of our other standards. So if you want to facilitate a withdrawal, like I've been kind of going through in prior slides, you have to first authenticate with SEP10, proving that you're the account holder of the account that you want to withdraw from. If you want to send remittances from one country to another, you have to authenticate with the organization that you're sending the payment to in order to get to the recipient. And so this authentication mechanism is necessary, but it actually didn't have the support for memo and multiplex addresses. And that's what we added to accommodate for this use case. Before these changes, when you authenticated via SEP10, you authenticated a Stellar account. And what this did is this gave you a token that gave you access to the entire history or transaction history of the account. But if you're a user of a pooled account and you get a token that gives you access to all transactions for that Stellar account, you're actually getting access to a lot more than you need. And for security-minded individuals, this is not ideal. So what we did is we added memo and multiplex address support, which narrows the scope of the authenticated session and allows the anchor to only allow access to what the user needs, which is the transactions they've initiated in the past. So once we made those changes, we actually then changed the standards that use the authentication protocol to support this limited scope session. And so the main differences when it comes to the deposit and withdraw APIs is that the transaction history that comes back when you try to fetch your prior transactions are only the transactions that were initiated with that particular memo or multiplex address and not the actual on-chain account. When it comes to KYC information, you no longer have to, or you can actually identify users of a pool account instead of providing a Stellar account. And this was a major problem because our protocol actually didn't allow you to specify users of a shared account. Only one account could be associated with one user. And so this was a change that we had to make to support the real world use cases out there. And then finally, for cross-border payments, we also implemented a similar change where users could be KYC'd using memos or multiplexed addresses, and then they could be assigned on the back end and they could know who these users are with the same pooled account. Okay, so the next use case we're going to talk about is wallet identity verification. And for those of you who may be a little bit more involved with the protocol's development, a word we were using at the time was client attribution. And so what this is at the high level is it allows wallets to identify themselves when authenticating via SEP10. Because prior to this change, authentication using SEP10 was just between the user and the anchor. So this allows wallets to actually identify themselves with the anchor service that they're enabling the user to authenticate with. And this is really important because oftentimes wallet applications have commercial agreements with the anchors that they're facilitating transactions with. And these agreements could include, the anchor could require the wallet to identify themselves in order to access the service. They could actually offer some kind of discount to the users of a particular application. There's a lot of reasons why that the anchor may want to know who the wallet is when they're facilitating a transaction. And there's a lot of reasons why the wallet would want to identify themselves. And so we wanted to add this support in the Stellar ecosystem protocol or protocols so that this could happen in a standardized mechanism and wouldn't have to be some bespoke mechanism that each wallet and anchor had to decide apart from the standard. So to recap, the Stellar Web Authentication Protocol is a mutual authentication protocol for account holders. So I, as the user, have to prove that I own a Stellar account to the anchor, and the anchor has to prove that they hold a Stellar account to me. And therefore, I know who the anchor is, and the user knows who I am, and we have proven that we hold the Stellar accounts that we're advertising publicly that we want to transact with. So I kind of went over that quickly, but account holders have to verify that they possess the secret keys of the public keys that we advertise in these API calls. And then as an anchor, I'm not sending my public key in an API call. I'm actually advertising on a public file, a stellar.toml file, that I own a particular public address or a public account. And I am creating these authentication challenges with the signing key I'm publishing publicly to my to my file. So to kind of get a better visualization of this, this is kind of what a typical authentication scheme looks like. You have a user with a Stellar account, and the Stellar account is imported into the wallet using some mechanism. And the anchor on the other end hosts a public file at a well-known domain with a signing key. And that is how this file is how the user or wallet knows the account by which the anchor should sign the challenge transaction when they authenticate. So to initiate the authentication, the wallet makes an authentication request. The anchor returns a specially formed Stellar transaction that is signed by the anchor's signing key. And the wallet can verify that it's signed by the signing key by looking at the file that the anchor publishes, and then checking the signature on the transaction to verify that the anchor actually is the one that originated this authentication challenge. The wallet then signs or adds another signature to the challenge transaction using the user's public key and secret key, and sends that back to the anchor. And the anchor can verify that the account that they wanted to authenticate with, the client, actually signed the challenge transaction and is therefore in possession of the secret key and can therefore be associated with the account. Now, the wallet and its identity is actually left out here. The wallet is opaque to this flow, and the anchor is just authenticating the user and proving that they're the account holder. In order for the wallet to actually prove that they are involved in this flow, they actually have to host their own stellar.toml file with their own signing key. And what this does is it allows anchors to collect the signing key and verify that the signing key on the wallet stellar.toml file also signed the challenge transaction. So in addition to the user's signature and the anchor's signature, the wallet can actually add a third signature using the public and private key of the key pair posted on their TOML file. And they can pass that challenge back to the anchor after the third signature has been added. And this anchor can verify that not only the user owns their account, but that the wallet owns the account that was published to their TOML file, and can therefore identify that the wallet is the one facilitating the authentication between the user and themselves. So what changes do we actually make to the protocols to make this happen? Well, in order to enable this use case, wallet applications have to host a stellar.toml file. And this stellar.toml file has to have a signing key on the file. And that file has to be hosted on a domain known to the anchor, right? And so this is the important piece. So the anchor needs to know where to look for the signing key and verify that the signature on the transaction passed back to the anchor is actually from the signing key on that file. So the wallet application has to pass that information and tell them where to look. Where is this public file and where is the domain on which I can find it? And that's actually encoded in the second change here, this manage data operation that was added to the challenge. When the challenge is returned to the wallet application, it's going to have an additional operation. And the source account on this transactions operation is going to be the signing key of the wallet. And the wallet passed this key to the anchor and said, here is the signing key that I'm going to use to sign the transaction. Here is the client domain that you can find the signing key on. And then they sign the transaction and pass it back. And so when the anchor receives this transaction, after it's been signed by the wallet, they can look at the signing key in the additional manage data operation and verify that there's a signature on the transaction that matches that public key. And then they can therefore tie that public key back to the anchor's domain, the wallet's domain, because the wallet provided it in an earlier API request. So in that manner, the signature on the transaction can be tied to the signing key of the wallet, and the anchor therefore knows who the wallet is and who they're interacting with. So again, this can be used for a variety of use cases, but the bottom line is that the anchor can now know the applications that are facilitating authentication and therefore transactions on behalf of their users and apply all sorts of discounts or different behavior per account or different behavior per wallet. Okay, and the third topic we're going to talk about is off-chain liquidity. And so what I mean by liquidity is the ability to exchange assets, right? And when I say exchange assets, especially on a Stellar presentation, everybody probably thinks about the decentralized exchange, the Stellar decentralized exchange that is a constantly evolving market on chain that allows for the exchange of assets that are on Stellar. But I'm actually going to talk about why sometimes the Stellar decentralized exchange should not be used, and there are valid reasons for that. And there are protocols that we've added so that you can use off-chain liquidity in a way that's standardized and everybody on the Stellar ecosystem can use. So before off-chain liquidity, we're going to talk about on-chain liquidity, or what the Stellar ecosystem was doing prior to these standard changes. And the way to transact assets, as I mentioned earlier, was to use path payments on the DEX. Right. And so path payments exchange one on-chain asset for another. And so if you were trying to facilitate a remittance from a sender to a recipient, two different organizations would, one would send a particular asset using a path payment operation, and that asset would be converted into the recipient's asset, or a recipient's asset that's equivalent to the one that they want to receive, such as sending dollars and then receiving euros. And the recipient of that payment, of that path payment, would then provide the off-chain equivalent to the recipient. So as a sender, I could send dollars to my mother in another country, but those dollars would actually show up in their bank account as euros, and that liquidity that was used to exchange those assets was actually on-chain using the DEX. The problem with this flow is that I, as the sender, don't know what rate of exchange I'm getting when I exchange my dollars for euros, because the decentralized exchange is a constantly changing and dynamic market. And so prices are fluctuating just like any other market. And this is a problem for businesses because they obviously want to provide quoted rates to their users. And so this was a point of contention when trying to build these services. And so we changed our standards and made sure that they could actually do this. So the main change that we did was we actually switched out the use of path payments for just regular payments. So now the sending anchor that's facilitating this transaction doesn't have to convert assets. They just send the on-chain equivalent of what they received from the sender. And instead, the receiving anchor receives that on-chain asset, but exchanges it for an off-chain different asset, euros. And the sender is actually in the know on what the rate is between those dollars and euros before sending the funds. So I, as a sender, would go to the sending anchor and say, hey, I want to send $100 to my mother in Germany. And the sending anchor would say, okay, one moment, and would look up the exchange rate that the receiving anchor is actually offering. And the receiving anchor would provide that exchange rate. The sender would say, okay, that sounds like a good rate to me. Provide the dollars to the sending anchor. The sending anchor would make the transaction. And when the receiving anchor receives the payment, they would then deliver funds to the recipient at the quoted transaction, or at the quoted rate. And so in this manner, the sender knows the exchange rate that is being used and has a chance to approve it before actually going through with the transaction. Businesses don't have to hold floats of receiving assets. So, another workaround, instead of using the DEX, was for the sending anchor to provide or to hold a float of the asset they have to send to the recipient. And sometimes this could be an issue because the business either didn't have the license or the bank account infrastructure necessary to hold the destination asset, or they didn't want to hold a currency that may be inflationary and lose value as it was sitting in a bank account waiting to serve users. So in this manner, the receiving anchor who's actually making the exchange is the one that provides the quotes, and the sender can still know the rate ahead of time. So a classic example of this, I'm trying to bring up use cases of how this is actually being used, is N tokens in Brazil. They're actually going to be implementing the standard, which are going to allow senders from all around the world to send USDC while they can deliver Brazilian fiat to their users in Brazil. And so this is a very powerful mechanism because it allows N tokens not to be exposed to Brazilian real, but it does allow for senders to know the quotes that they're going to be getting when they facilitate these transactions. So finally, what are the changes that we actually made to make this happen? Well, what we did is we created a new SEP, an Anchor RFQ API we call SEP 38. And this allowed for anchors who were receiving payments on behalf of senders to provide fixed and indicative exchange rates. So they could provide a price feed of estimates, but they could also provide firm exchange rates that they were going to hold to if they used that exchange rate, or if they used that quote ID that they were given within an appropriate amount of time. And once we created this standard specification, we actually integrated it into the other standards that facilitate transactions, such as our deposit and withdrawal and cross-border payments APIs. And so in this manner, client applications request an exchange rate for asset A in exchange for asset B. Anchors provide the rate and the quote ID that they're willing to provide. The user has to, or the sender has to, be okay and accept that exchange rate. And that quote ID is then used when initiating transactions, and the anchor that is facilitating the transaction can tie that quote ID back to the exchange rate that they promised that they would uphold. And that's how funds are exchanged and done in a standardized way. Okay, and that is the end of my talk. I know that was a little bit fast, but you'll be able to review these talks on the Meridian site or on YouTube. And if you have any questions, please send them my way. I really appreciate it, and have a great day.